Okay, so continuing with the indefinite integral, you might notice that some questions are very long and confusing, and the way to make it easier is to use the substitution rule. So this is just showing, if you did take the antiderivative, how we can get there. So the first part is expansion. So if we expanded our binomial out because we're multiplying it by itself, and we took the derivative of it, or antiderivative, sorry, we would be taking the antiderivative of 4x squared plus 4x plus 1. And then if we wanted to now actually take that antiderivative, we can now apply the rule to go the other way, and we would end up with 4 over 3x cubed plus, that ends up being 2x squared plus x, and then we're also adding in c. Now, the other way we could do this, so this is your answer and we're done, but what if that exponent was like 3 or 4 or 20, right? That would be a lot harder to expand out. We can still do it, it would just take a lot of time. So the other way we can do it is doing U-substitution, where we're still taking the derivative of that 2x plus 1 squared, but instead we say let u equal 2x plus 1. So the inside of that bracket. Then we can take the derivative of u, so du over dx, and you would just get 2. Now what we want to do is get dx alone. So if we isolated dx, so multiplying it up and dividing the 2 over, dx is going to equal du divided by 2. So now we can sub back into our integral. So we'll have u squared, and then the dx equals du divided by 2. Now we can go ahead and take that antiderivative, and we would end up with 1 over 6 times u to the power of 3 plus c. So we can expand all of this out, or sorry, I should just replace this back in, which ends up being 1 over 6 times 2x plus 1 all to the power of 3 plus c. So now if we expanded this all out, it is going to equal that first derivative, or antiderivative. And when I teach this in class, we would actually go ahead and do that. But right now, just trust me, those are going to be the same. And in the first one, this might look easier, but when it gets more complicated, U-substitution is going to make life a lot easier. So looking at a few more examples, like this 5x plus 1 to the power 3, if we wanted to take the integral of that, we'll go and do that same thing and say let u equal 5x plus 1. So this would be u to the power of 3. And then we also had, it would be dx. Actually, let's write that out first. So if I had 5x plus 1 to the power of 3, and I want the antiderivative, so I still have that u is 5x plus 1. If I went and took the derivative of u, it would be du over dx, and it would just equal 5. Then get dx alone, doing the same thing, and you're going to have du divided by 5. So now we can go ahead and plug in, taking the antiderivative of u to the power of 3, and then replacing dx with du over 5. So this whole thing is divided by 5, so just keep that in mind once we go ahead and take that antiderivative. So we would have u to the power of 4 du, oh sorry, that goes away, over 5, and then we'd also have, bringing that 4 down, 1 over 4 in front of it, and then we'll have plus c. So we can simplify this, replace u back in as 5x plus 1 to the power of 4, and then dealing with our fractions, we'd have 1 over 20 in front, and then still plus c. So we've made it a lot easier, and we didn't have to expand all of that out to do that same work. This next one, same idea, taking that antiderivative of 3 over the root of 6x minus 2, and this will all be dx. We can say let u equal 6x minus 2, then take that derivative of u, and that will just equal 6. Get dx alone by moving or just swapping this part, and we'd have dx equals du divided by 6. Now we can go ahead and plug back in, and once we plug back in, you're going to have 3 over u to the power of a half and then we'll have du over 6. So we're taking the antiderivative. So this part here will reduce, and I'm just going to rewrite this one more time and bring that u to a negative exponent. So it'd be u to the negative 1/2 times du, and this is still all over 2. So now let's go ahead and take that antiderivative by using our rules, and we'll have 1/2 that was already there times u to the power of now positive 1/2, and then we're dividing this all by 1/2 and adding c. So we'll simplify our fractions, replace u back in, and we'll end up having 6x minus 2 to the power of 1/2 plus c, and our fraction ends up canceling, and will just equal 1. So that's our little bit of our lesson. And then if I just picked some of the harder questions from page 511 from the Intro to Calculus textbook, and just to try a few of these, just showing that same U substitution and how it's helpful. So looking at that first one, again, we're going to let u equal what's a little bit more complicated on the inside, x squared plus 4. Then we'll take that derivative of that expression, so du over dx will equal 2x, and then isolate dx, and so dx will equal du over 2x. So let's go ahead and do some replacing. We have x times u to the power of 8, so replacing that, and then times du divided by 2x. We'll see that x canceling, so let's simplify that. U to the power of 8 du, and this would be divided by 2. And then we can go ahead and take that antiderivative, and when we do that, we'll end up with that half is still there, but you'll have now u to the power of 9 all divided by 9 plus c. So let's deal with that fraction and replace our u back in, and this ends up being 1 over 18 times x squared plus 4 to the power of 9 plus c. So again, this would be a lot faster than expanding this out and then dealing with our rules. So if I look at the next one, which is on page 511, we have the integral of x squared times the root of x cubed plus 2 dx. So let's again, the one that's a little bit harder here is that inside, let u equal x cubed plus 2. Take the derivative, du over dx equals 3x squared, and then rearrange, and we'll get dx equals du divided by 3x squared. So let's go ahead and replace in. We still have x squared in the front. Then we'll have times u to the power of 1/2 times, we're replacing dx with du over 3x squared. We see our x squareds canceling nicely. We can rewrite this as 1 over 3 u to the power of 1/2 du. And now let's go ahead and take that antiderivative. So 1 over 3 is still there, times u, and we're going to add 1 there. So we'll have u to the power of 3 over 2, that's a 2. And then divide all of this by 3 over 2 plus c. So let's replace u back in and go ahead and divide that fraction, and we'll end up with 2 over 9 times x cubed plus 2 to the power of 3 over 2 plus c. So there is one more here we can take a look at, and same idea, it just saves you time if we let u equal the inside. So x plus 6, take that derivative, du over dx equals 1. So when we take a look and isolate dx, du equals dx. Now, taking that derivative, you have u to the power of 10 times du, because du equals dx. And then we can go ahead and do the math. So we'll have u to the power of 11 divided by 11 plus c. And we just have to replace this back in. So we'd have 1 over 11 times x plus 6 to the power of 11 plus c. So that's our very quick video to show how using U-Substitution can make finding the antiderivative more helpful. If you did find this helpful, please subscribe, and I will have more calculus videos coming up. And if you're taking Chem 30, please check out my channel along with my website. And if you find that helpful as well, please subscribe. Thanks for watching.